Hi everyone, good afternoon, and thank you so much for joining us today. On behalf of BM Infotrade, I'd like to welcome you all to today's webinar on how I'm Anushka Mathur and I'll be your host for this session. And we are really glad to have you here with us. Now, when we talk about modern cybersecurity, one of the biggest challenges SOC team faces is handling the sheer volume of alerts. Manually investigating every alert is not only time consuming, but it also increases the chances of missing critical threats. This is where source security, orchestration, automation, and response becomes extremely important. It helps SOC team automate repetitive tasks, respond faster, and improve overall efficiency. Before we begin today's webinar, let me quickly take you through what we'll be covering today. We'll start by understanding the need for SOAR in modern security and SOC environment. Then we'll see how SOAR can be integrated into an existing SOC setup. After that, we'll understand that SOC workflows, what really are and why they matter. We'll also walk through how SOC workflows are actually created. Then we'll finally showcase the real workflows built by our team and how they work in practice. At the end, we'll be open for a Q&A session, so feel free to drop your questions in the chat anytime during the session. Now, moving on to the main part of today's session, we are joined by Mr. Rahul Sharma, who is Senior Cybersecurity Engineer at BM Infotrade, and along with him, we have Ms. Divya Sharma, who is Junior Cybersecurity Engineer. Both of them have extensive experience working with SOC team and implementing security automation solutions. We're really excited to have them with us today to share practical insights and real world workflows. With that, I'd like to invite Ms. Divya Sharma to take the session forward. Over to you, Divya.
Yes, good evening, everyone. Today, I'll be presenting you about security, orchestration, automation, and response, or SOAR in short. So, we are not here to define what SOAR is in textbook terms. Instead, I'm going to walk you through how SOC teams actually build those workflows in real environment, what works, what breaks, and what we have implemented in our own SOC. So these are some of the topics that we'll cover. So we'll cover how workflows are designed from real alerts, how decisions are made inside automation, and where human validation is still critical. So towards the end, I'll also demonstrate two real workflows that we have built using SOAR, and we have integrated it with our SIM solution and threat intelligence platform, and explain to you how exactly they work step by step. So, most SOC teams today are not struggling because of lack of tools. They are mainly struggling because of too many alerts and too little time. So, in a typical environment, it's very normal to see thousands, sometimes even tens of thousands of alerts per day coming from SIM. Now, here's the problem. Out of those alerts, a large percentage are false positives or low priority events. So, what happens? Analysts spend a significant amount of time doing repetitive tasks. They check if an IP is malicious, they look up domains, they correlate logs, they copy paste data between tools. So, let me give you a simple scenario. If an alert comes in for a suspicious IP address connecting to a server, what does the analyst do manually? They copy the IP, they check it in threat intelligence platform, they look at historical logs, and then they decide if it's malicious or not. This entire process can easily take up to 5 minutes for a single alert. Now multiply that by 500 alerts. You can see where the bottleneck actually is. And this leads to increased mean time to respond, delayed incident handling, and analyst fatigue and burnout. And the biggest risk, critical alerts getting buried under noise. So, this is exactly what the problem space is. And this is where the SOAR comes in. So SOAR doesn't replace analyst, it removes the repetitive mechanical work so that analyst can focus on actual investigation and decision making. So now that we understand the problem, let's see what SOAR, like where SOAR actually fits inside a SOC architecture. So at a high level, every SOC stack has three critical layers. First is detection. So this is handled by SIEM platform. So this is where the logs are collected, correlated, and alerts are generated. Second, we have enrichment. So this is where threat intelligence platforms comes into play. They help us answer questions like, is this IP known to be malicious? Has this domain been seen in previous attacks? And third, we have response. And this is where SOAR platform operates. So SOAR sits in the middle of everything and acts like an orchestrator. It take alert from SIM, enriches them using threat intelligence, make decisions, and then triggers actions across different systems. So here is an important point many people miss. SOAR is not just automation, it's orchestration. Automation is doing one task automatically. Orchestration is coordinating multiple systems, multiple decisions, and actions in a sequence. And one more important thing, SOAR should not directly replace decision making in high risk actions. So, in a mature SOC environment, you will often see a hybrid approach. Like low risk actions are fully automated, high risk actions requires analyst approval. And this balance is what makes SOAR effective instead of dangerous. So now let's break down what a SOAR workflow actually is, because there is a lot of misunderstanding here. Many people think a workflow is something like, if an alert comes, block this IP. In reality, that's an oversimplification, and honestly, that kind of approach can break production environments very quickly. So a real SOAR workflow is more like a decision engine. It consists of multiple stages. First, we have the trigger. Second, we have the enrichment. And third, we have decision making. We'll explain this step by step in the next slide. So, every workflow, no matter how simple or complex it is built using mainly four components. First, we have the triggers. So this is how the workflow actually starts. In most SOC environment, the primary trigger is a SIM alert coming. Typically, this is received as a webhook containing a JSON payload, for an example. But triggers can also be some scheduled jobs like periodic scans. They could be manual triggers by analyst. They could be external API calls. And second, we have enrichment. This is one of the most critical steps. At this stage, the workflow gathers additional context to make better decisions. And third, we have decision logic. This is where workflows becomes intelligent. So instead of blindly acting, the workflow evaluates the conditions. So if the IP is malicious or just unknown, has this alert occurred multiple times? Is the affected system critical? So this is implemented using if else branching, thresholds, and sometimes scoring models. Last, we have actions. So this is where the workflow actually does something. So typically actions include like block this particular IP on your firewall, disable this particular user account, send some alerts to email, Teams, or Slack channel, and also create a few tickets using ITSM tools. So workflows are mainly use case driven. So first of all, what we need to do is we need to define it. We need to define our use case. We need to tell like what would be the trigger from SIM. What are the required data and enrichment via threat intelligence platforms? We need to also set automation boundaries. We need to identify like what would be the decision criteria. If like an alert is a low risk alert, Can it be automated easily, reducing the manual labor of our SOC analyst? Or if it's an high risk alert, does it require approval of a SOC analyst of level 3? And then lastly, we need to implement our logic. So we apply logic using conditions and using thresholds. So first of all, we have to validate with test alerts and the failure scenarios. We have to think about all the edge cases that could happen. So usually when we talk about a particular SOAR workflow, the trigger could be a SIM alert, it could be a webhook, or it could be a scheduled job. And when we talk about enrichment, so like here the workflow actually gathers all the data, like what is the IP reputation, what is the domain intelligence, what are the historical logs that we have, what is the asset criticality, and third, we also need to define our decision making. So, like, this is where the logic will be applied. So, we need to think about that the target system is critical or not. How many times this particular event has occurred, and whether this particular IP is suspicious or malicious. And finally, we have to take our action. So, like, when you think of a SOAR workflow, don't just think of it as a script. So now let me define what are the key mistakes that an SOC analyst or a SIM engineer can actually make while making their workflows. So first of all, there could be a design issue. There could be a design issue about doing some sort of over automation without validating it first. And there could be some false positives too. I also request all of you to be please attentive because like after this presentation is completed, we will be giving you a live demonstration of our environment of how SOAR workflows actually work. So yes, as I was talking about, like what are the common mistakes that people actually make. So like first of all, we need to tune out all the false positives. And teams usually get very excited when things are about automating everything. So for an example, if a suspicious IP comes, they'll be like, block it immediately. It does sounds efficient, but in reality you end up blocking legitimate users sometimes, and business operations also get impacted. So I have personally seen cases where internal scanners or VPN IPs were blocked because just because they looked suspicious or just because it looked like an external IP. The second mistake would be to check the lack of validation. So workflows often assume that data is always correct. But in reality, there are some fields that may be missing. Some data may be malformed. There are some APIs that may return unexpected results. So, if you don't validate inputs, your decisions usually becomes very unreliable. Third, we have hard-coded logic. So, for example, in your SOAR workflow, where the IP should be dynamic, people usually hard code it. They like give it like a fixed IP list. They set up a static thresholds. So this makes the workflows very rigid and difficult to maintain. So a better approach is dynamic logic based on context. Last, we have like on fourth number, we have no logging or visibility. So if a workflow runs and there is something that goes wrong, can you answer like three questions? First, what decision was taken? Second, why was it taken? And third, what actions was executed? If not, you cannot debug or improve it. And fifth, we have no error handling. So imagine a scenario. Imagine a scenario where a workflows queries a threat intelligence platform.
Hello, hello. Yeah, hi Parimal. Good evening. Um, yes, please tell us. Anushka, could you please check if Parimal can unmute himself?
Yes, Parimal, you can unmute yourself and ask your query.
Okay, so we will continue our presentation. So we were talking about what are some of the mistakes that the SOC analyst can make while. Okay, so I guess we have a question.
Okay, Ria will be taking the question after this session is completed. So just wait a minute or so, like a little more.
Okay, so let's continue. Yes, so we were talking about what are the common mistakes that a SOC analyst can actually make. So we were on no error handling. So, like imagine a scenario where workflows queries any threat intelligence platform and the API fails. So, workflow automatically assumes that there is no data. That means everything is safe. So, we need to also think about this because here now a malicious IP is also getting ignored, and like that's a serious gap. And finally, there is no rollback mechanism. So, if your workflow blocks an IP or disables a user, you should always have a way to reverse that action. Otherwise, a single mistake can cause major disruptions. So, the takeaway here is very simple that SOAR is powerful, but like without proper design, it can create a few problems. So, a good workflow is not just about automated, it is controlled, validated, and also observed. So, whenever we talk about our designing methodology of a SOAR workflow, we need to first think about like what enrichment sources are we going to use. Okay, so if we are, for an example, including a threat intelligence platform, which platform will it be? And will it suffice all of our requirements that we have for that particular use case? What decisions are that needs to be made? We should like a lot of SOC teams usually make mistakes over automating too early. So, like if you are even disabling a particular user's account, you should require approval. You should set a very strict condition on when should that user be disabled. Otherwise, if a user is disabled without any sort of issue from their side, then it could cause a huge problem for your IT team. And whenever we are trying to implement our particular use case, we have to think about it that are we going to block it immediately, or are we going to set a boundary? Like for an example, if a particular IP is marked only by one vendor, are we going to block it, or do we need to increase this number to 5 or 8? Like you need to decide this particular number according to your goal, then only blocking actually makes sense. And like that's how logic is actually led. So, like in a real SOC environment, we try to simulate alerts, we try to test all of the edge cases, and we also validate all of the outputs. So, a good SOAR workflows always include like different parts, because like if failures are not an if, they are usually a when. So overall workflow design is less about dragging nodes in a tool, uh, like any SOAR tool. It's more about thinking like an analyst and translating that thinking into logic. Okay, so that was all about the PPT. Now let's see some live action. So give me a minute. I'll log in all of my required tools and I'll reshare my screen. Okay, so this is one of the SOAR workflow about getting an login failure alert. And if the IP is external, then we'll try to extract that particular source IP, and then we'll check it through a threat intelligence platform. And if it is found as malicious, we will send an alert to the Microsoft Teams, and then we will block that particular IP on our firewall, and again send a notification to the teams that yes, this particular IP is successfully blocked on firewall. So let's go through this step by step. First, we have our alerts coming from a SIEM solution. So here we are using a webhook And through the webhook, we are taking all of the alerts regarding login failures, and then those alerts are coming into our SOAR through that particular webhook. So, like, this is the URI that we used for that webhook. And next, what we are doing here is we are extracting the source IP from that uh, webhooks alert, and we are using regex for it. So, like from the full log itself, we are here providing our regex to extract the source IP only. And after that, we are checking it through a threat intelligence platform. Like we are giving the source IP as an input to the threat intelligence platform to check and tell us whether that IP is malicious or not. So we are giving it a URL, the URL of a threat intelligence platform that is hosted in our environment only. And in the body, we are giving it that particular source IP as an input, and also providing the headers like the authorization headers and the content type, so that it can send a post request to that threat intelligence platform. And here we have also included a condition. So the threat intelligence, like we need to here look at what the output is that the intelligence platform is giving to us. So according to that, I have set up a condition here. So what this condition does is it checks whether the threat intelligence platform gives us any response. So when it doesn't found that particular IP as malicious, there won't be any response, like the response would be zero. So that's why we have set up a condition here that if the response is greater than zero, that means that IP has been found as malicious, and only then this next node will be triggered. So next we have send to teams, which what it will do is it will send an alert to the Microsoft Teams channel that the SOC analyst can see. So here we have provided the URL, we have integrated it using webhook, and then we have provided the body. And here we have given like what text we want to be shown on our Microsoft Teams as an alert. So here we have written that this is the firewall alert, this is the source IP, and this was the full log that was received from the login failure alert. Next, we are blocking it on the firewall. So here we have given everything in the URL itself. In the URL itself, we have given our API key, and we have also given it that what address group we want to add our IP to. So like you can't just provide your firewall an IP and it will block it. You have to create a particular object address group on your firewall, and give that address group a tag, and then mention that tag and that address group's name in the URL itself, and along with the API key. So it will authenticate first to towards your firewall, and when the authentication is successful, it will try to find that particular object address group and add that malicious IP into that address group. And as soon as an IP is added into that address group, there will be a policy on firewall, a policy about blocking all the traffic that is coming from these malicious IPs. And lastly, what we are doing here is we are again sending an alert on Teams using webhook that yes, the firewall has automatically blocked the IP and it was success. So, like how exactly we are knowing that this IP successfully blocked. So we have also included here the firewall status. So if the status is 200, that means yes, the IP is successfully blocked. If it gives anything other than 200, that means no, the IP wasn't blocked. So that's why we have included the status here just to confirm. Okay, so now that the workflow is clear, let me show you a response that this workflow gave us. So this was one of the run that was conducted, and here we can see that first we are getting this particular alert from the webhook. So this is a SIM alert. It is about global protect VPN login failed. This is the log that was received. We'll open all the fields to see what this is actually about. So here we have the log. So we can see here that this particular, like this is the IP 185.251.19.201, which is like an external IP, and it was trying to log in, but but like the log is about like invalid username or password and the authentication failure. So now that we received this log in our SOAR workflow, next we are extracting the IP using regex. And as you can see here, we successfully got the IP, we extracted it. Then we are giving it to the threat intelligence platform. So here the threat intelligence platform has given us the attributes, all the headers, like what type of activity that IP was involved in. And then there is this send to teams node. So it has also given us a status 200. That means the team's message was sent, which I'll show you. So here you can see that this was the team's message that we received on a channel named as SOAR updates. So this was like a firewall alert. This was the source IP, and this was the full log that we received. This is the exact same log that we just saw. Next, we have block Palo Alto. So the status is 200, but there is an error. Why? Because this particular IP has tried again. So the error is only because that IP already exists on our blacklisted IP address group. So let me show you the IP on our firewall. So this is our firewall, and this was the address group named as blocked IP that we created just for this SOAR workflow. And here you can see that this is the exact same IP, and it has added it in our address group. And now whenever this policy related to this address group will be triggered, it will automatically block any sort of communication from these IPs. And lastly, we have again Teams node, which is just like an information to the SOC analyst that yes, this particular IP was successfully blocked. So here it is, the second message that Palo Alto auto block was successful. This was the blocked IP, and this was the firewall response. So like you can see here that like the firewall, like whenever a malicious IP is there, the firewall gives an alert on this Teams channel. So that was all about this particular workflow. Now we'll move towards the second one. Okay. So this is our another workflow. So this is a workflow that we have made to disable an Microsoft Intune's account of a user, and also disable their Windows Hello methods, like the pen and the fingerprint that they try to sign in. So this particular condition will be triggered if an internal user of our organization tries to log into their system after a few retries. So that like totally depends upon your use case, what you're looking into. So for now, we have made it as 8. So if an internal user tries to log in into their own laptop and they failed 8 times, so their user account will be disabled. They'll need to contact the IT person to enable their account. So we have done this because there are cases where if an attacker gains access to our internal systems, and if he tries to log into a particular endpoint or user's account, then like the account should be disabled so that they don't get into our systems. So again, here we have used the webhook to get those alerts, like internal login failure alerts from the SIM solution. And then here we are getting a graph token. Now, Microsoft, like this was done through Microsoft Graph API, and we need to authenticate into it first. And to authenticate, we need to get a token. So we have given it the URL, and we have to give it our tenant ID. So you can get your tenant ID, application ID, and all the secret keys and the permissions by registering an application into your Microsoft admin portal. So we have given it the tenant ID, the client secret, and also the scope, like the URL that they have to go to get that particular token. So as soon as they get the token, now the next step would be to look up that particular device. So here we are taking the login failure alert from the SIM solution and try to get the device ID. So like this is the URL that we have used to get the ID. So this is like a Microsoft Graph URL that we have used. And once we get the ID of the user, then the next step would be to check the device state first, like whether the device is currently active or not, what is the uh, device registration state, and other things. And as soon as we get those, we have to extract the user ID from that. So here we are using a short Python code to extract the user ID. First of all, we are giving it the raw data, the raw log that we received, and then we extract our user ID and print it. So this is the code that we used. And after that, in this particular node, we are disabling their account as soon as we get their user ID. So this like is like a very simple URL that we used. We are just searching their user, like in the users, we are searching their user ID and then disabling it. So what will happen is not only they won't be able to log in from their endpoint, like even if they try to access their particular organization's email ID through any other laptop, they won't be able to log in from there too. And if they have Microsoft Teams open anywhere, that Microsoft Teams would also be disabled. Like they also won't be able to sign into their Microsoft Teams ID. Next, we are also disabling the Windows Hello methods. So to get the Windows Hello's method, again, we are using this URL where we are getting Windows hellos for business methods. And after getting those methods, like what are the methods that particular user is using to sign in? It could be a PIN, it could be a fingerprint, it could be their face ID. So here we are extracting the two particular IDs. One is for the PIN, and one could be for the fingerprint. So, for an example, and again, we are using Python code to extract that particular ID. And after getting it, we are deleting those Windows Hello key from their endpoint so that not only they won't be able to sign in through their normal password, now they also won't be able to sign in through their PIN or fingerprint. So let me now show you one of the example. So we have this Intunes portal here, and like this is one of our users, and currently you can see that his account status is enabled. So here I'll just quickly run this workflow and see that if this particular user's account get disabled or not. So let's just give it a few seconds. Okay. So first, it gives output for all the nodes. So first we have the graph token. So the status is 200, and this is the access token that we got for the Microsoft Graph. And then we are looking up their device here. So this is the value that we got. This is the device ID. This is the user ID. This is the device name, and we also got the operating system and what is like the management agent here. We also we also got the device registration state and everything about that particular user, even their username and the display name and everything. Next, we are checking the that particular user's device state. We need to know if the what is the device enrollment type. So here it is written that it is Windows Auto Enrollment and the management agent is MDM, and yes, the device registration state is registered. So we need to make sure that the device is registered on the Microsoft Intunes. Next, what we are doing is we are extracting the user ID that we got from above two outputs using the Python code that I just showed you. And then we are also getting their Windows Hello methods. So here we got their Windows Hello data. And in this, we are disabling their user. So let's see if let's like refresh this and see if the user got disabled. So yes, we can see that the account status is disabled. So that user got disabled by running this workflow. And there was the user must not have set any sort of pin or fingerprint. They must be logging through password. That's why it didn't got any key here. So that was all about our two workflows. If anyone have any questions regarding this or regarding the PPT, they can ask.
Yeah, so if anyone have any questions, you please type it on the chat or you can unmute yourself and ask. In the meanwhile, we have got some questions like what is the full form of MISP? It's Nitin Kumar. So, Mr. Nitin, MISP is a threat intel platform and it stands for Malware Information Sharing Platform. And Miss Ria has asked us how your SOAR is unique as compared to other OEMs. So, like, I would like to answer this in a way that we are not comparing here any specific product of a specific OEM. We are here to just showcase you the capabilities of SOAR and the workflows of SOAR and how SOAR actually works and what are ourselves like, what capabilities we have. So it's a SOAR point of view, not a specific product's point of view. And um, so yeah, if anyone has any questions, you may please shoot it to us. So no questions. Okay, so I guess we are good to go now. Yeah, over to you, Anushka.
All right, now, thank you everyone for joining us today. We hope this session gave you a clear understanding of how SOC teams can leverage SOAR to automate the workflows and improve their security operations. Thank you once again and have a great day ahead.